So now we've talked about the t-distribution and finding confidence intervals for the mean using the t-distribution. And now I'm going to look at what happens if we want to compare two populations. So the idea here, we actually have two different populations that we want to look at, and we want to compare and see how they relate to each other. And we're going to have a couple of ways to do that, but for now we're going to start with confidence intervals. And we're going to once again use the GeoGebra Graphing Calculator app to do that. Before, when we looked at confidence intervals for means, we used the t-mean estimate. This time, since we have two means, we need to use the t-mean 2 estimate. We're going to have to input the first sample mean, standard deviation, and sample size. Then we move on to the second one, the second sample mean, standard deviation, and sample size. We then have our confidence level, and then we're going to have this false command at the very end. So let's just jump straight into some examples of this. So here I'm looking at a problem where we looked at college students who both volunteered for community service and those who didn't, and we found a way to measure their attachment to their friends. And so on average, the people who performed service, their attachment was rated at 105.32. On average, the people who didn't do service was 96.82. And then we have their sample standard deviations and their sample sizes. We want to find a 99% confidence interval for the difference. So essentially what we're looking for is a way to estimate this mu1 minus mu2, the first group minus the second group. And that's what we're doing when we're comparing two means and confidence intervals. So in order to do this, we're going to need our t-mean 2 estimate. We then enter the information for our first sample, so the first mean, standard deviation, and sample size. We then enter the mean, standard deviation, sample size for our second group. Next, we need our confidence level, in this case 0.99. And finally, when we're dealing with two means, we need to have this false command at the very end. And now that we have all of that, we can move over to our calculator and type it in. So here's the GeoGebra Graphing Calculator. I'm going to hit the 3 dots at the top of the keyboard. Scroll down to Statistics. We're looking for the t's, and we're looking for the t-mean 2 estimate. We then enter in the information. The first mean was 105.32. Standard deviation was 14.68. Sample size was 57. For the second group, our sample mean was 96.82. Standard deviation was 14.26, and the sample size was 17. Our confidence level is 0.99. And then we can click over to the ABC and type the word false. So we have our estimate is between negative 2.5 and 19.5. So what exactly does this mean? Well, there's a 99% chance that the actual mean of the service students minus the mean of the non-service students is between negative 2.5 and 19.5. But more exactly, essentially you'll notice there's a lot more positive numbers here. The range of positive numbers is a lot bigger than the range of negative numbers. So that means there's a really good chance that mu1 is actually bigger, that the service students were actually more attached to their friends. However, there is the chance that 0 is in this interval, so we can also say that there's no difference, or even that the service students are less, because there is a possibility that this is negative. And this is a 99% chance. So there is a 1% chance that it's outside of this range. Let's do another example. So the next example, here we're looking at the amount of rapid eye movement that people get. We're breaking up our two populations into children and adults and trying to see if children need more REM sleep than adults. So here's the data for our two groups, and we want to find a 95% confidence interval for the difference. We know we need to use the t-mean 2 estimate since we have two samples here. We start by entering in the information for the first group, their mean, standard deviation, and sample size. We then enter the information for the second group, their mean, standard deviation, and sample size. We then have our confidence level, in this case 0.95. And finally, when we're dealing with two samples, we need to add the false. Now that we have this, we can move over to our calculator. We hit the 3 dots and select the t-mean 2 estimate. Our first group had a mean of 2.8, standard deviation of 0.5, sample size of 10. The second group had a mean of 2.1, standard deviation of 0.7, and sample size of 10. We wanted a 95% confidence level, and with two groups, we need to type false. So it's somewhere between 0.12 and 1.28. We now know there's a 95% chance that the true difference between the amount of REM sleep that children need and adults need is going to be in this range of 0.12 and 1.28. But the big takeaway is to realize that this entire interval is always positive. So there's a 95% chance that children are going to need more REM sleep to make this difference positive. So there is a 95% chance that the children actually do need more REM sleep. And we can even say that it's somewhere between 0.12 and 1.28 more hours per night.